Welcome to July 31st LeetCode Challenge, Trapping Rainwater. Given a non-negative integer representing an elevation map with the width of each bar is 1, compute how much rainwater it could trap after raining. So you're given an elevation map called height, and each of these width here is 1 unit, and each of these height in the array is the height of it. So for instance, you have height of 0, which is 0, height of 1, 1, height of 0, 0, height of 2, 2, and so on. So the black represents the elevation, and the blue represents the amount of water that's storing inside it. So there's a couple conditions, some things you want to note here. So the boundaries right here, you see this unit of 1, and you see this height elevation of 0. There's nothing on the left side of the boundaries to hold the water inside, so therefore you can't store any water in this area. However, if you have a height distance of 1, a space distance, and then followed by a distance of less than 1, the one previously, and you have a max height of 2 here, you know that you can store 1 unit of rainwater in between. Likewise, if you have a height unit of 2, a height unit followed by a height unit of 1, followed by a height unit of 2, you know you can store 1 unit of water in between them. There's no boundaries to the right either, so you can't store any rainwater on this side. So that's kind of the general premise of it. You want to know what is the algorithm to be able to calculate how many units of water it could hold in this elevation map. And this one is 1, 2, 3, 4, 5, 6. It can hold 6 units of rainwater. So there's various ways of doing this. You could use it using dynamic programming. Solve it using stacks. I'm going to solve it using 2 pointers. And the intuition behind that is basically to move your left pointer. So you have a pointer here, and I'm going to keep track of my my height, the difference as well. So you want to find the minimum of the left pointer and the right pointer as you move along, and you want to know, is this pointer the maximum, right? You have 1 here, and then followed by a 0, you iterate through it, and then you have a 2. So the minimum of these, if you have this right here, so you have 1 here and 0 here. So you know that the 1 is followed by a 0, so you know the minimum of both these is 0. So then, therefore, you could potentially store amount of water here, right? A unit of water. So what we're going to consider is things that have pockets in it that we can store water. So I'll walk through the code here and see how we're going to go about solving it using 2 pointers. So the first thing I'm going to do is initialize a variable called water. And this is going to be water units, I should say. And that's going to be assigned to 0. That's going to be our output. And then next thing I'm going to do is initialize the left pointer and the right pointer. So left is going to be equal to 0, so it's going to be the most left-hand side value, and right is going to be our equivalent to the length of the height. Yeah, minus 1. Alright, so we initialize the 2 pointers now. We want to basically iterate through it using 2 pointers. So the usual left, while left is less than right, because we want that to be true. And also we want how we're going to move our pointer. So we're going to move our left pointer to the right while these conditions are true. So while the left pointer is less than the length of our height, and our height at the left pointer is less than or equal to 0. Now what does this mean? So obviously our left pointer has to be less than the length of the entire array, makes sense. And the height of the left pointer is less than or greater to 0. So because we don't want to consider things ending with the height of 0, because anything less than 0 or ending in 0 will not help us fill any water, because we can't fill water in those areas. So then we're going to move our left pointer by 1, incremented. And then how we're going to move our right pointer. So while our right is greater than or equal to 0, and our height of our right pointer is less than or equal to 0. Same deal here. We don't want to consider anything ending with a height of 0. And also, it will help us fill water as well. We want to move our right pointer to the left. Alright, so those two conditions are met. So if the left pointer is less than the right pointer, then what we're going to do is, actually I don't think I need that. No, we don't, because the condition is already in the while loop. Alright, so what we want to do is define a variable called difference, right? The difference is going to be the min between the height of the left pointer and the height of the right pointer. Because we want to subtract this from the array of elements to calculate the amount of rainwater we have. So they're going to initialize that. So for j in range, call this for blank in range. No, for j, for I in range of left to right plus 1. What we want to do is if our height at j is greater than or equal to 0, then we want to reassign height at j to be decremented by the difference. However, if the height, and then when that's true, if the height at j is less than 0, then we want our water to be incremented by negative height at j. No, what am I doing? J. Else if the height, what is going on? Oh. Height at j is less than 0, then water will be incremented by our difference. And height of j will be decremented by difference. At the end of this, we want to return water. Let's see if this works. No. Let's see. Let's try this. If left is less than right. Okay, accepted. Awesome. So this is using the two-pointer method. This is basically, so the water trap depends on the map, the pointer to the left. So in a similar case, if you have your height at your left and the height at the right, you want to find the minimum of that. So we want to know that we're going to show that the water trapped would be dependent on the height of the bar of the current direction from left to right. So as soon as we find a bar on the right that's smaller, right, that's why we're using the min value, we can start iterating the opposite direction, and then we just kind of we have the basically keep track of the height at j, and then we just minus the difference, and then we just keep on adding the water to it, the difference. So yeah, and it's a horrible explanation of this for sure, but the time complexity is big O of n, because we do one major wait. There's actually a better way of doing this. This actually is not very efficient. Let's just say that this is it's not the most efficient way, but it's big O of n, because we iterate through at most n times, and space complexity is big O of constant space, because we're storing everything in just one variable. Yeah, constant time space complexity. There's another way of doing this to make it a lot easier. You know what? I think this is actually... Yeah, this is probably actually using brute force, not using 2 pointers. But otherwise, no, this is actually probably big O of n squared. Yeah. Alright, that's it. Have a nice day, guys.